All right, clip number 4 for section 3 notes on areas of polygons. This one's going to be a solution process to number 23 from the homework assignment and big ideas. In number 23, we're simply told two things and asked to solve for the area of the given octagon. Number 1, we are dealing with an octagon. Number 2, the radius of that octagon, or the distance from the middle of it to one of its corners, is 11 feet. And that's it. That's what we're told. So based on that information, we're going to have to find the area using this formula. Now, first off, this octagon name does directly tell us what n is. In this case, n is going to be 8 for the number of sides to an octagon. That is something we can really just apply directly into the formula. Now, similar to the last clip, I do need to find two pieces of information. Namely, I'm going to need to find lowercase a, the apothem length, the distance from the center of the octagon to one of its 8 sides, and then s, the distance or the length of one of those 8 sides along the octagon. But since I don't have a picture to work with, I'm going to have to create the triangle wedges myself. So this will take some getting used to on your part, but basically anytime I'm dealing with this area, I'm just kind of generically creating a triangle wedge slice, where this side here represents one of the 8 sides of the octagon. This side here represents the radius or distance from the center to the corner. And then the apothem is what's going to split it directly in half. So if you can set yourself up with this kind of wedge slice each time, where this is side length s, this is lowercase a, the apothem length, and then these two sides here are going to be the radius length. You'll be given some combination of things. In some cases, I don't even have to worry about doing the trigonometry we're going to do here. I just need to find apothem length, the distance from here to here, and s length, this side here. And if I'm given those two pieces of information explicitly, I don't even have to bother with this. I just plug it in and do the calculator work. But let's keep going. The other piece I'm given here is that the radius is 8. That's each of these legs, for the record. And what I'm fundamentally going to be doing is I'm going to be taking out, say, this top little slice, this top sliver of this to create a right triangle. I'll use the blue apothem length to demonstrate that. Right triangle slice. And I'll call this X now, but this X slice is just the half of the full side. So if I can solve for X, I can just double it to find full S. And this is still 8 units on top. So all this is the top sliver here. All right, using the fact that this full angle is 360 degrees divided by the 8 sides of this octagon. Solving for that, 360 divided by 8 gives me 45 degrees. So in a regular octagon, there are 8 triangle slices. Each of those wedges would be 45 degrees. If you were to add up 45 degrees 8 times, you'd get to the 360 degree full interior. Based on that number, I can actually figure out what for each of these little slivers here it has to be, because this apothem has to split it directly in half. So this here is exactly half of 45 degrees, which is 22.5 degrees. Yes, it's a decimal, but still just a number in a calculator for us. As this information is shown right here, thankfully, thanks to trigonometry, this is enough information to solve for both of these legs of this right triangle. If I solve for one, I can use Pythagorean theorem to solve for the other. Whatever you're most comfortable with, feel free to run with it. I'm going to demonstrate trigonometry twice here. All right, so since I'm using trigonometry, I'm going to be using the mnemonic SOHCAHTOA to figure out what ratios I'm going to be creating. I'm going to try solving for apothem first. It really doesn't matter if you could solve for x first and then double that length to find s. It doesn't matter the order I do this in. But I'll go ahead and start with apothem. So I have this angle. I have my hypotenuse, right? Apothem is the adjacent side to this angle. So adjacent for A, and then hypotenuse will be H. I'm going to be using CA, or cosine, for my apothem work. And so that C for CA is going to be cosine of that 22.5 degrees is going to equal adjacent over hypotenuse in this fraction. The adjacent side, or the next two side to this angle, is this A. the apothem length. The hypotenuse in a right triangle is always the one that's opposite the 90 degrees. Okay, so the 8-unit length here is my hypotenuse. There's the adjacent over hypotenuse ratio for cosine. This is just a number in a calculator. So if I want to solve for A, I need to multiply this 8 to the other side. And I'm going to get 8 times cosine of 22.5 degrees. Oh, I'm realizing right now that this whole time I've been putting in 8. The radius is 11. So if you were confused at any point, that's what happened. Let me correct that right now. So if you felt like you were going crazy, it was me that was crazy. So that's 11, which will now change that denominator to 11, that hypotenuse length. All right, you're not crazy. Your teacher just made a mistake. All right, so anyway, that also changes to 11 now. That's multiplied out front. Now we're good. Okay. So for the record, this 11 times the cosine of 22.5 degrees. That's just calculator work. So let me just do that really quickly. Cosine of 22.5. In my calculator, I have to put the degree measurement first. 22.5. Cosine is this cosine button right there. Gross decimal. That's okay. Multiply whatever that result is by 11. This tells me the length of my apothem. Let's go to 2 decimal places. So 10.16 is about my apothem length, the distance from the center of this octagon to one of its sides. That result will be plugged in directly into my area formula. So now I need to worry about finding the side length of one of these 8 sides of the octagon. So let's go back to this sliver. Again, if I can solve for this unknown side right here, I simply have to double its length to find the full side of one of the 8 sides of the octagon. So in this case, I'm going to use the same angle measurement. I'm going to use the same 11. For the record, you could use Pythagorean theorem at this point. Now that you know that apothem is 10.16, you could say 10.16 squared plus this x squared is equal to 11 squared. And you could solve for x that way. You should get the same result. And then whatever you got for x, just double it again to get this full side length. So if you're more comfortable with Pythagorean theorem, by all means do that. Otherwise, I'm going to use trig again. So that's opposite side to that 22.5 degrees and still hypotenuse. So opposite O, hypotenuse H. I'm going to be using SO or sine right here. Let me drop down below here. So I'm going to use the SO or sine now of that same angle measurement, 22.5 degrees. But now the ratio is going to be opposite over hypotenuse. Based on that triangle, opposite was that unknown x, hypotenuse was 11. So solving for the x, I'm going to multiply 11 to this other side. Looks gross, but it's just a number in a calculator. So if I do 11 times the sine of 22.5 degrees, sine now is this sin button, gross decimal, multiply it by the 11. That tells me the length of that shorter side. Let's go to 2 decimal places. That's about 4.21. Okay, just again describing where that was in our diagram, that 4.21 in this sliver is this side right here. So we have 10.16, 4.21. It makes sense that both of them are smaller than this 11 because that 11 should be the longest hypotenuse side of the triangle. But anyway, 4.21 is this little distance from the apothem up to the corner. So if I want to solve for the full side length, I'm going to take that value and double it because this lower right triangle is the same exact thing. Okay, so 4.21 times 2 is going to give me my full side length. So my side length here of one of the 8 sides of the octagon is going to turn into about 8.42. This will be the other piece I'm plugging in. So now I have lowercase a apothem, lowercase s for the side length of one of the sides of the octagon. The number of sides, lowercase n, would be 8. So for the area formula now, I'm just plugging in these values. Area will end up being 1/2 times a, which was 10.16, times n, the number of sides of an octagon, which is 8. Let me erase a little bit of space here. And then S was that 4.21 times 2, or 8.42. And now I just do the calculator work. 10.16 times 8 times 8.42. That's those three multiplied together. Just remember to cut that in half. Divide by 2. Let's go to 2 decimal places. Area is about 342.19 square units. I think they just use regular units. I described them as feet, so this would be square feet. One last little thing to point out here. If you were to plug this exact number into big ideas, they'd mark you wrong. But let me show you what the correct answer is. That's the correct answer. You'll notice that they're very, very close together. They're actually only 0.05 apart. This is why I don't grade on accuracy in big ideas, because the only difference between these two results is the fact that I rounded the 10.16 and the 8.42. What big ideas would expect you to do is to write this as 11 times the cosine of 22.5 degrees, and this as the 11 times the sine of 22.5 degrees. Okay, and then you would just round at the very end. So all of that error, the fact that we rounded twice along the way, made a difference of 0.05. So again, I want to emphasize that's why I don't grade on accuracy on big ideas, because if you rounded too many times, it would mark you incorrect. So for the record, if you're looking for what to plug into number 23 on big ideas, it'd be this guy right here. But that's your freebie. But the math there is the same, and that small margin of error just simply had to do with the fact that we rounded along the way. All right, that will conclude that clip. This will be archived with the rest of the Section 3 notes as just another opportunity to look at how to solve these problems.